So hello and a warm welcome to the third video in this little series where I describe the design choices and differences between my robot design and the base design of Onion Robotics AR4. And now we come to the joint 3 of the assembly, which also incorporates the arm assembly. So as I described in the previous video, the arm encapsulates the belt system, belt and pulley system for the joint 3. The joint 3 actuates the robot in this direction, and the joint 3 motor is placed at the bottom to minimize the moment arm of the heavy J3 motor. So the J3 motor gets keyed into the J3 pulley, and the J3 pulley transfers the torque to the upper J3 pulley, and this pulley transfers it via a 8mm steel rod into the J4 turret housing. Also different from the base design, I have used different screws to go from the J3 bearing cup into the J4 arm, J2 upper arm. So if we would examine this, you would see that I have used M4 through holes in the J3 bearing cup, and I used those screws through directly into the plastic, which is why I used M4 instead of M3, because of the larger diameter and so that the M3 pulleys screws don't just lose their holding power over time. And I found that M4 works a little bit better for this application. They also get screwed quite a lot in, basically longer than 12.7mm. And I didn't want them sticking out, that's why I minimized it, so we still have a nice surface. The bearing cup encapsulates one of the J3 bearings, tapered roller bearing, which gets seated into here. So if we look at the J3 assembly again with the printed parts in place, there we go, but without the arm, you can see that here is the upper pulley, and the torque gets transferred into this metal key, metal shaft. And I also had to design a little flat spot into the pulley and had to file it onto the shaft because of the high mechanical demands of this part. So this is stuck onto and held in place via 4 M4 grub screws, and the torque gets transferred via this shaft into the J3 spindle and J4 turret housing, which are combined in my assembly into one part. And the metal shaft is glued into place via epoxy glue, which provides a strong enough bond so that it doesn't work out. I also put in place a little grub screw, but I found that it doesn't really provide much support. So if you can imagine, here's the keyway, the metal shaft which is normally keyed, and hold in place via epoxy glue and a little M for grub screw. And now we can see the bearing surface of the opposing bearing set, which is not a tapered roller bearing set, but a axial bearing set. Yeah. I think I put the wrong thing in place, or whatever. And it all gets preloaded via this aluminium plate, which I made by hand. And it's held in, and this aluminium plate is held in place via 4 M3 screws, which go quite deeply into the part. So if I could select the bottom surface, it's quite a distance. So the machine screws don't damage the plastic over time. Yeah, that's the J3 assembly. So now we'll get to the J4.